Okay, so we are going to start today's lesson by talking about geometric sequence. So we did arithmetic sequence in our previous lesson, and today we're looking at geometric sequence. So what is the difference between the two? In arithmetic sequence, I'm giving you an example. One of the most common arithmetic sequence that I can think about is 2, 4, 6, 8, and so on and so forth. What do you notice here? The sequence is growing by, if I add a constant number, the difference between these two is 2, again 2, again 2. So there is a d involved. There is a d involved, which is the difference between a term and the previous term, a term and its previous term. In case of geometric sequence, which I'm going to write as g dot s dot, this is an example of a geometric sequence. I start with the same 2, I go to 4, once I go to 6, I go to 8. From 8, I go to 16. So what do you notice here? You notice that it is growing by multiplying a particular term with a number, a constant number. So 4 times 2 is 8, 8 times 2 is 16. And this number is basically a ratio. We call that as a ratio because 4 divided by 2 is 2, 8 divided by 4 is 2. So it's always a constant, which is a 2 in this case. And that's what we talk about. A sequence where the ratio of any term to its previous term is constant. So it has a ratio. The minute it has a ratio, it becomes a geometric sequence. So at this point, I'm going to let's quickly look at it in a very generic way how a geometric sequence is written. So the first term is a, that's just a 2. The next term is a multiplied by r. So 2 multiplied by 2 gives me 4. And then the following term is same ar, but you multiply that by another r, so it becomes ar squared. And then you take ar squared and multiply that by another r, so it's ar cubed, and so on and so forth. So every term over the previous term that is being multiplied by r, or if you divide it, you get that r. So there are two definitions, just like in arithmetic sequence, a recursive definition and an explicit definition. And both are, pretty much you saw both of them in arithmetic sequence, and they mean the same thing. When I say they mean the same thing, an explicit definition is when you have a formula for a specific nth term. So that's what we say an. Whereas in this case, the an is dependent on the previous term. That's recursive. That means you're basically depending on the previous term. Whereas in this case, it's a standalone formula. I can go to any nth term. So if you look at your formula sheet, I'm going to introduce that now, and we're going to look at the geometric sequence. If you look at the geometric sequence, these are my two formulas. The first formula is basically my explicit, because there is no an minus. This is the explicit formula because it's a1, the first term, multiplied by r n minus 1 term, which is what we saw. Remember what I said? ar squared, ar cubed. So anytime I want to go to a particular nth term, it's ar raised to a particular power, and that power is nothing but n minus 1. And this is your recursive formula because an is dependent on the previous term. So it's always saying is the previous term multiplied by r. In a recursive, you also always want to write what's a1. That you always should mention what is a1. Alright, and that's what we talked about here too. In this one, an is dependent on an minus 1 plus d, and in this case, an is not dependent on a1. It's not dependent on an minus 1, it's just a1 plus n minus 1d. Alright, so having said that, these formulas are nothing but coming from the formula sheet, as long as you understand where these are coming from. So one more time, your recursive formula is dependent on the previous term multiplied by r, whereas your explicit is a standalone an, which if you know the first term and you know what the ratio is, you can get to any specific term. Alright, so you can write down these things from the key, but I'm going to go ahead and look at some of the examples, which will give us a better understanding of what a geometric sequence is. Is this a geometric sequence? If yes, what is that? I cannot even read. A1 and r. Okay, so it's asking for the a1 and r. So I thought that was a specific term. Okay, so for me to even check if it's a geometric sequence, what I need to do is I need to divide 6 by 3. So 6 divided by 3 is 3. Then 12 divided by 6 is also 3. 24 divided by, 2. Did I say 3? Why did I say 3? 24 divided by 12 is also 2. 48 divided by 24 is also 2. So yes, it is a geometric sequence where my ratio is 2. I'm sorry about saying that was a 3. I don't know what I was thinking. So the ratio is 2 and my A1 is 3. Alright, so let's look at the next one. So if I look at this one, x10 divided by x5, that's going to be x5, right? When you divide x15 divided by x10, that's also x5. x30 divided, so x5, x10, x15 and x20. So x20 divided by x15 is also x5, which basically means my ratio is x to the 5th power and my A1 equals x to the 5th power. I'm sorry, I'm hesitating a little bit because I'm not able to see these subscripts very clearly from where I'm sitting. So, but basically if you can see that, so my answer is yes again, because there is a ratio and the ratio is x to the 5th power. Okay, let's keep going. So decide whether the following sequences are arithmetic, geometric, or neither. So if it is arithmetic, there is a D involved. If there is geometric, there is an R involved. And if neither of them are constant, it's neither. So let's look at each one of them. For example, the first one, I'm going to check whether it is arithmetic sequence. I'm checking, I don't know. So for it to be an arithmetic sequence, if I subtract 5 over 2 minus 5, what does that give me? That basically gives me, I need to have the same denominator, so multiply top and bottom by 2 in my second term. So 5 over 2 minus 5 times 2 is 10 over 2, which gives me same denominator, negative 5 over 2. Now let's check the second one. 5 over 4 minus 5 over 2. So I want the same denominator because I'm subtracting top and bottom with the 2. So it's 5 over 4 minus 5 times 2 is 10 over 4, and I get 5 minus 10 is negative 5, but my denominator is 4. So there is no D involved. There is no D involved, that's a constant, so it is not an arithmetic sequence. Let us see if it is a geometric sequence. Let us see if it's a geometric sequence. Because of lack of space, I'm getting another piece of paper and see if it's a geometric sequence. For it to be a geometric sequence, you have to divide. So 5 over 2 divided by 5 is nothing but 5 over 2 multiplied by 1/5. And what does that give me? That gives me half. Then again I divide. I divide 5 over 4 divided by 5 over 2, which is nothing but 5 over 4 multiplied by 2/5. And that gives me 2 over 4, which is half. 2 over 4 is nothing but half. And you keep going and you'll find that the ratio is half. So it is a geometric sequence, yes, because there is a ratio which is equal to half. So I tested it only for the first two, but we should not stop at the first two. We should keep going, like 5 over 8 over 5 over 4 should also give you half. So it is a geometric sequence. Alright, so you should be able to test that for each one of them, and you can look at the key and see if each of them is an arithmetic sequence or a geometric sequence. So I'm going to keep this on for 5 seconds more before we go to the next page, and the next page is going to be continuation of seeing a little more of the same stuff. Okay. Alright, so moving right along to the next page. Let's see if I can switch on the light here. Let's see if it gets brighter so I can see better. Yeah. Alright, so now let's look at this. It says write the first 5 terms of the geometric sequence. So they already tell us that it's a geometric sequence. A1 equals 1. The first term is 1, and every next term I am multiplying by half. So my A1 equals 1. My A2 becomes previous term multiplied by half, which is half. And then A3 equals previous term multiplied by half, which is 1/4. A4 is previous term multiplied by half, which is 1/8. And then A5 is previous term multiplied by half, which gives me 1/16. So these are your, oh, I'm sorry, we lost focus. There we go. So we should be able to find all the subsequent terms by just multiplying by the r. So in this case, there's no r involved, but as long as I keep increasing the n, a1 equals -2, 1 plus 1, which is 2, so this becomes 4. A2 equals -2 raised to the power of 3, which becomes -8, and so on and so forth. I'm going to let you guys finish A3 and so on and so forth. Okay, the next one says, what are the indicated terms of the geometric sequence? Find the tenth term. So you're trying to find the 10th term of 4, 12, 36. Okay, I can find any specific term as long as I have the explicit formula. So what is the explicit formula for any geometric sequence? It's an, I'm just looking at my formula sheet and writing it down. So my explicit formula is a1 multiplied by rn minus 1. So which basically means I'm trying to find the 10th term, which is a1 is 4, right? 4 multiplied by the ratio. So now I need to find the ratio. I didn't find the ratio. So ratio is nothing but 12 divided by 4, which is 3, or 36 divided by 12 is also 3, so that my ratio is 3 raised to the power of 9, because 10 minus 1. And go ahead and put this in your calculator and you should get 78,732. Alright. The next problem that we see here, find the second and third term, is actually better suited for the next lesson, which talks about the mean, the geometric mean, finding the in-between terms, but we'll get to that in a minute. But so I'll rather save it up when we get to the next page. I just want to do one problem under example 21 before we go to the next page. So here it says, write an explicit formula for the nth term of the geometric sequence and then find A6. And what do we notice here? We notice here that we have A2, -20, A4, -5. I'm going to go ahead and do B. B is, I feel, a little better suited for this. So before I do that, our first job is to find what is my, I have A2, so A1 is missing, A2 is 45, this is missing, and -1215. So for me to even write the explicit formula, I need to find the r. How do I find this r? I do know A2, A3 is missing, A4 is missing, but A5 is there. So how do I get from here to here to here? So there's one r involved, there's another. If I multiply 45 times r, I'll get this. If I multiply this with another r, I'll get this. If I multiply A4 with another r, I'll get this. So how many r's am I multiplying? I'm multiplying 45 by r cubed to get to -1215. So let's go ahead and look at this. So r cubed equals -1215 divided by 45, which is -27. That means r equals -3. So now that I have r to be -45, yeah, now that I have r to be -3, I can find my A1. So how do I find A1? You have to basically, A1 multiplied by -3 gives me 45. That means A1 equals 45 by -3, which is -15. So I found A1. And then, so I have A1, so that means I can write my explicit formula. My explicit formula is going to be AN equals -15 multiplied by r raised to the power of -1. That is my explicit formula. And using the explicit formula, I can find any term. Using the explicit formula, I can find any term. Alright, so we will stop the lesson for now, and we will pick up in the next video with the next page.